Hi Ken, this is the inverse proportion homework from yesterday. Now you would have heard me use the word indirect proportion, and it's referring to the same thing. And so inverse proportion can also be called indirect proportion, or another word for proportion, we also refer it to as variation. So we can call it inverse proportion, inverse variation, indirect proportion, or indirect variation. These are all referring to the same relationship. Now, more specifically, when we say that two variables are inversely proportional to each other, so in this case, if we're told that y is inversely proportional to the variable x, we can write this as an equation with the first variable being equal to a constant over the second variable. And remember, the constant up here is called the constant of proportionality. So like with direct proportion examples, we are going to be using this equation to solve our problems. Let's have a look at our first question. We are told that y is inversely proportional to x. If y is 5, x is 3, and we want to find an equation linking the variables y and x. And so we can start off with the equation. Y is equal to constant over x. Now we're not done with our equation yet because we're given an extra information about the equation. We are told that y is 5, x is 3. And so we can substitute those in. Now I'm going to write this again at the top. 5 is equal to k over 3. And solve this equation for k. I want to get rid of the 3 at the bottom. And so I do that by multiplying by 3 on this side. And because this is an equation, I do the same thing on the other side. Okay, so I get 15 is equal to k, or k is equal to 15. So I can now substitute that back into my original equation, which would give me y is equal to 15 over x. And that's your answer, linking your y and x here. For the rest of the homework, you do the same thing. And so question 2, P is inversely proportional to Q. Okay, so we can write that as an equation. P is equal to K over Q. Okay, we are told when P is 2, Q is 7. So we substitute those in. So P is 2 when Q is 7. Okay, and then we solve for x. And we do that by multiplying both sides by 7, because we know 7 divided by 7 is 1. And so we get k is equal to 2 times 7, which is 14, which we can now then substitute back into the original equation right here. Okay, and that would give us P equal to k over, sorry, you know the k, 14 over Q. Now the question is only asking us to find the equation, and so that would be your final answer. Now the next question is a little bit different, but the steps that we go through to answer this question is pretty much the same. Okay, so we're told that A is inversely proportional to this second variable. So we first write down our equation. A is equal to k over root b. We also told that A is 4 when B is 9. So we can substitute those in. So A is 4 when B is 9. All right, and then we can solve for k. Now we know what root 9 is. It's 3. And so to solve for k here, I need to multiply both sides by 3. The 3's cancel out to give me k. k equal to 12. And so we can now substitute that back into our original equation here, which will give us a equal to 12 over a second variable, root b. And that's our answer. So I hope you are able to see the pattern of working out here. Okay, question 4. Y is inversely proportional to x. So we can write that equation down. Y is equal to k over x. We're told that when y is 3, x is 4. So 3 is equal to k over 4. We can now solve for k by multiplying 4 on both sides to get k is equal to 12, which we can now substitute back into our original equation to get y is equal to 12 over x. And that's my equation linking x and y, so I can write down the final answer here. We want to find out what y is when x is 2. So we just substitute 2, x equal to 2, into our equation. So y is equal to 12 over 2, which is 6. The next question is find the value of x when y is 9. So we substitute that into the equation. Y 9 is equal to 12 over x. I'm going to show you a shortcut to solving this equation quickly, but before I do that, I want to show you why that works, or where that shortcut comes from. And so when we are solving an equation, we want to make sure that the subject is in the numerator. So we're going to take this x in the bottom up to the top, and we can do that by multiplying both sides by x. Okay, because x would cancel out, and we get 12 on the side. On the left-hand side, we have 9 times x, which is 9x. All right, and then we can find out what x is by dividing both sides by 9, and that will give us 12 over 9. So as you can see from the original equation, the position of the x and the 9 has switched over. And so in the future, if you have an equation of this form where your pronumeral is on the denominator, you can just switch the 9 and the x. You can use that result. X would be equal to 12 over 9. That's our answer here. The last question, we're told y is inversely proportional to x. And we're asked if x is tripled, what would happen to the value of y? Okay, so let's have a look at our first value of y. If y is equal to k over x, all right, that will be the case. Then our second value of y, when we triple the x, will be k over 3x. Let's have a look at a specific example to see what the pattern is here. So if y is, let's say it's equal to 1 over, and let's say we have chosen x to be 3. Okay, then in our second y, the k is still the same. It's 1. It will be over 3 times our value of x, which is 3. What if our x was 5? Then it would be 1 over 5. Okay. And when we triple the value of x, which is 5 in this case, it will be 1 over 3 times 5. And so the difference is between the two y values across is that when we triple the x value, we are multiplying by another third. Okay, so we go from a third to a third times another third, from fifth to a fifth times a third. So the answer would be, if x is tripled, okay, the value of y is multiplied by a third or divided by 3.